This is section 11.6, events involving not and or, and then odds. This section is fairly long because there are a bunch of small little topics in it, and I've made sure that I've worked a lot of examples for you. So be prepared here, okay? In this section, we're going to see a lot of connections with the stuff we did in chapter 2, which was set theory. And then chapter 3 was the logic. I made a lot of connections between those two chapters when we did chapter 3. But a lot of the formulas that we got earlier are going to come back. Now the notation may be a little bit different because now we're talking about probability, but the ideas are the same, okay? The event not E is called the complement of E, and that's exactly the same terminology we used in sets. If we talked about a set, like everything inside a Venn diagram, if this is E, not E would be everything on the outside of it, okay? Now, we do have some formulas for finding the complement of a particular probability. If you want to find the probability that something is not E, you can do it directly, or sometimes it's going to be easier to find the probability that E does happen. So in that case, you can just find the probability that E does happen and then subtract it from 1. Remember that if you add up all the different probabilities in a sample space, it needs to add up to 1. So if we find the probability that P does happen, then the probability that it doesn't happen includes everything else in the sample space. So the probability that E does happen plus the probability that E does not happen needs to equal 1. That's where these two formulas come from. And they do work both ways. So if you need to find the probability of E, but it's easier to find the probability that it doesn't happen, you can do that and then subtract it from 1. Okay? So let's talk about some connections here. All right. I mentioned the sum of probabilities equals 1. And if an event is guaranteed to occur, then its probability is also 1. Okay. Remember from sections 3.3 and 3.4, we talked about tautologies. And this was something that is always true, which would be kind of like the event being guaranteed to occur. It's always true. P or not P. So this would be the probability that something happens or that it doesn't happen. That was a tautology. So it's always true. They're going to add up to 1. All of this, we're talking about the same concepts from many different angles. Okay? So, some example problems. Suppose you are dealt 1 card from a standard 52 card deck. Find the probability that you are not dealt, first of all, a 3. So there are a lot of different possibilities for not getting a 3. Okay, so let's find the probability that we are given a 3. So the probability that we do get a 3 would be, we're just choosing 1 card, so we don't have to worry about 52, choose 3 or something like that, just 1 card. So they're out of 52 cards total. How many different ways can we draw a 3? Well, there are 4 3s in there. So the probability of that would be 4 over 52, which reduces to 1/13. Okay, so the probability of not E would be 1 minus the probability that it does occur. Not E, I meant to write 3 here, not 3. So this would be 1 minus 1 over 13, which would be 12 over 13. Okay, let's find the probability that we do not draw a club. So let's first find the probability that we do draw a club. Well, there are 13 clubs, and there are 52 cards. So the probability that we do draw a club is 13 over 52, which reduces to 1/4. So the probability that we do not draw a club would be 1 minus 1/4, which is 3/4. Okay, let's talk about the ways we could the probability that we do not draw a red picture card. So the probability that we do find red picture would be, out of 52, how many different red picture cards do we have? Well, it's Jack, Queen, King of hearts and diamonds. So there are a total of 6 different picture cards, 6 different red picture cards. And this reduces to 3 over 26. So the probability that we are not dealt a red picture card would be 1 minus 3 over 26, which would equal 23 over 26.